Okay, we have introduced the structure of causal, how to compute causal attention. Here is a summary before we move to the code and examine how this is implemented. Well, here comes the data, which is some sequence of tokens, and each of token is represented as a vector. Those vectors will then be transformed into keys and queries. Um, so you use the query to uh, associate to relate to the key. This is called self-attention. And be noted that after computing the self-attention, we can apply some mechanism so that the attention can only allow one token to be related to the token happens before it, or some kind of designated range. And then this attention is combined with the values, and the values is also another kind of transformation from the input. All that has been computed, the the result will have another transformation before it reaches the final output of the attention block. And we put a direct link from the input to the transformed the attended block, so that this part of the module only needs to compute the residual in this step of data transformation, which makes the training easier. Okay. If we call this entire structure a block, okay, we have the input of the block and the output of the block. We can stack multiple such blocks together. Let me move my note a little bit. Okay, after several this kind of transformations, hopefully, with training data, the model will learn how those tokens need to relate to each other to generate some output. In a supervised learning scheme, we can let the final representation of the data to form a feature vector, which is then transformed into, I have used the circles for information on data, but this is a square, but you get the point, which is then transformed by a structure to form some prediction of the probabilities of some predictable target, which we call that a classifier, of course. And this will be used as a decoder structure in our later study. Okay, we now will have a look of the entire structure here and the structure here. Okay, and how to implement them.